In this second lesson, we are going to study in detail about energy conversion and conservation using everyday real-life examples. This is important because physics examination questions are set using everyday events. If you know how to apply the concepts to explain the science behind how things work, you will excel in exams. Let's begin with the simple pendulum. When you exert a force to raise the pendulum bob to one side, the energy is transferred to the pendulum, and it gains in gravitational potential energy as it is raised to a height higher than its original position. When it is released and swings down, it gains kinetic energy because moving objects have kinetic energy. It loses gravitational potential energy because it is moving to a lower position. As energy cannot be created or destroyed, the gain in kinetic energy must have been converted from the loss in gravitational potential energy. Kinetic energy is at its maximum at the vertical position. The kinetic energy enables the pendulum to swing to the opposite side. As it swings to a higher position, the kinetic energy is converted back to gravitational potential energy as the pendulum rises to a higher position. The loss in kinetic energy causes the pendulum bob to slow down. When it loses all its kinetic energy, it has only gravitational potential energy. The pendulum reaches the maximum height possible when it does not have any more kinetic energy to swing any higher. It will then start to swing back. As it swings back, the gravitational potential energy is again converted to kinetic energy. In an ideal world, the pendulum will continue swinging as energy cannot be destroyed. However, in a real world where there is frictional forces, as the pendulum swings, some of the energies that was initially exerted to raise the pendulum is converted to heat and sound energy due to frictional forces. The heat and sound energy is dissipated to the surroundings and cannot be converted back to kinetic or gravitational potential energy of the pendulum. As a result, the pendulum will stop. Now let's look at another example, the bouncing ball. As the ball falls, the gravitational potential energy is converted to kinetic energy. The kinetic energy is converted back to gravitational potential energy as the ball bounces up. It reaches maximum height when all kinetic energy has been converted. Note that the height of the ball after each bounce up from the ground gets progressively lower due to loss of energies to the surroundings as sound and heat energy. Finally, let's look at the roller coaster. The motor provides a force to pull the roller coaster car to the top of the hill. It transfers energy to the car. At the top of the hill, the car has gravitational potential energy. As the car glides down, its gravitational potential energy is converted to kinetic energy. At the bottom of the hill, all its gravitational potential energy has been converted to kinetic energy. And this kinetic energy enables the car to accelerate and run back uphill. Now let's summarize the concepts. First, when an object moves to a higher position, it will gain in gravitational potential energy. When it moves to a lower position, it will lose gravitational potential energy. When the object is moving, it must have kinetic energy for it to move. Hence, in the entire process, energies are converted accordingly because the principle of conservation of energies states that energy cannot be created nor destroyed. It can only be converted. So in the real world where there is frictional forces, energies are lost to the surroundings as sound and heat energy. With this concept, you will be able to explain energy conversions and conservation of any real-life system.